These are examples for section 14.6, spheres, surface area and volume. Example 1. What is the surface area of the sphere in terms of pi and rounded to the nearest square meter? Here we have a sphere, and when we show a sphere, of course we draw a circle, but we also indicate this ellipse here to show that it's got the third dimension in it. So, in this sphere they're asking for surface area, and of course this sphere does not have lateral surface area because the whole thing, there are no sides to it. So surface area, SA, according to your notes, it's 4 times pi times the radius squared. So everything that covers the sphere. So we come over here, notice our diameter is 10 meters. We need a radius, which of course is the 10 meters divided by 2. So the radius is 5 meters. That's all we need. So the surface area is 4 times pi times the radius, which is 5 meters, squared. So the surface area is 4 pi times 5 squared is 25. So the surface area is 4 times 25, which is 100 pi square meters. Approximated, rounded to the nearest square meter, the surface area, using your calculator, 100 times pi, is 314 square meters. So about 314 square meters of the surface all around the sphere, completely around it. Example 2, geography. Earth's equator is about 24,902 miles long. The equator, all the way around the Earth. What is the approximate surface area of the Earth? So we're looking for surface area again, this time of the actual Earth, which is a sphere. Round the answer to the nearest 100,000 square miles. 100,000 square miles. Then write the answer in scientific notation. So the equator represents a certain type of measurement on a sphere, since it goes all the way around it, and the center is at the center of the sphere. This would be the circumference. So the circumference of the sphere, the Earth, is the equator's length, 24,902 miles. So using the circumference formula for a circle, which is 2 times pi times the radius, we substitute this in for the circumference. 24,902 equals 2 times pi times the radius. So we find the radius. Once we find the radius using this equation, then we can find the surface area using the radius that we found. So in this equation, we're solving for r, radius. Notice that r is being multiplied with 2 and pi, so we can divide both sides by 2 and pi, both factors. The 2's divide out, the pi's divide out, and we're left with r. On the left side of the equation, 24,902 is even, so 2 will go into it evenly. 2 will go into 2 once. 2 goes into 24,902 exactly 12,451 times. So we get 12,451 over pi for our radius. So our actual radius, according to this, is 12,451 over pi miles. Now we take our radius. We're looking for surface area of the sphere, so the surface area formula is SA equal 4 pi r squared. Substituting in the r, we have surface area is 4 times pi times the radius, which is 12,451 over pi squared. Next, we need to square both the 12,000 and the pi. So 4 times pi times 12,451 squared over pi squared. Now this is one large term. There's no addition or subtraction. Notice that the pi factor up here will divide out with one of the pi factors down here. So pi goes into pi once, and pi goes into pi squared, pi times 1 pi. So the surface area then leaves us 4 times, and then 12,451 squared on your calculator, you should get 155,027,401 over pi was left. Then, the only thing we need to do now is multiply 4 with this large number here. 4 times that number is 620,109,604 over pi. This is the exact, according to this, the exact surface area in square miles of the Earth's surface. They asked for an approximation first, and they want us to round to the hundred thousands place. So let's go ahead and get an approximation now. This is as far as we can go with pi. 620,109,604 divided by pi in your calculator gives us approximately 197,387,017.5 square miles. Now we want to round this to the hundred thousandths place, which is right here. So we look at the next digit. It's 5 or greater. It's going to push this up to 4, and all these become zeros. And we don't need that any longer. So the surface area of the Earth is approximately 197,400,000 square miles. There's our first answer. Then they want us to write this in scientific notation. Remember, in scientific notation, the larger the number, the more positive the exponent. The smaller the number, the more negative the exponent. And remember, it's in the form of the number times 10 to the power, whatever power we get. So scientific notation, we start with the decimal point, which is located here. It needs to move all the way over to this location so that the number, this first number n, is between 1 and 10. So 1.974. And then we stop right there once zeros start. And we count the number of places that we moved it over. So that's 1, 2, 3, 4, 5, 6, 7, 8 times. So this is times 10 to the positive 8th power square miles. Don't forget your times 10 to the 8th, not just times 8. So this is the surface area in scientific notation of the Earth's surface area. Example 3. Find the volume of the sphere in terms of pi and round it to the nearest cubic meter. This time we're looking for volume. They want us to round our approximation to the nearest cubic meter. That's the ones place. But they do want it in terms of pi, our exact answer. Here we have a sphere with a radius of 6. So a radius is 6 meters. The volume formula for a sphere is 4/3 times pi times the radius cubed, or to the 3rd power. So we have the volume is 4/3 times pi times the radius, 6 meters cubed. Now since we have a fraction, sort of like when we had the 1/3, you can always make all of these fractions since we're multiplying them all. So we have 4/3 times pi, or pi over 1, times 6 to the 3rd. Now remember, that's not 6 times 3, that's 6 times 6 times 6, or 6 times itself 3 times. That's 216, or 216 over 1. Since 3 would go into 6 evenly, it's got to go into 216 evenly, because 216 is a multiple of 6. So 3 goes into 3 once, and 3 goes into 216 exactly 72 times. Now we have 4 times pi times 72, or 4 pi times 72, over 1 times 1 times 1, or just 1. So we can leave it like that. Then we finally multiply the 4 and 72, and we get 288 pi cubic meters. Now, remember, this is the volume of the sphere. That's cubes that fill up the entire space inside that sphere. We also need an approximation. So the volume, using your calculator, 288 times pi, is approximately 905 cubic meters. Example 4. Find the volume of the billiards ball in terms of pi, given that the surface area of the sphere is 25 pi square yards. So they're telling us that the surface of this pool ball or billiards ball in square units is 25 pi square yards. Well, that's impossible. This would be more like centimeters. And they want us to find the volume from it. So the only thing the volume and the surface area for sure have in common besides pi as a variable and a measurement is the radius. So radius is going to connect the volume to the surface area, and vice versa. So we can go either way. Radius is the key. So they tell us that we got to find the radius first. We've got the surface area. So we start with surface area. We're going to go through the radius and come back to volume. Surface area here is 25 pi centimeters squared. And then the surface area formula is SA equal 4 pi r squared. So we substitute in the surface area here. We have 25 pi equals 4 pi r squared. Now we need to solve for r. First of all, since r squared is being multiplied with 4 times pi, we can divide both sides by 4 times pi. Over here, the 4's divide out and the pi's divide out. Over here, the pi's divide out, but 25/4 does not divide out. We have 25 over 4 left. On the right side, we have r squared. Don't change this to a decimal, because if you'll notice, 25 and 4 are both perfect squares, so that when we take the square root of both sides, r is equal to the square root of 25 over the square root of 4. Remember, you take the square root of both parts. And so the radius is 5 halves, or 5 halves centimeters. So here's our radius. Now that we found our radius, we come over to volume. The volume formula is 4/3 times pi times r, the radius cubed. Now we substitute in what we found for the radius, 5 halves, and cube it. So volume is 4/3 times pi times r, which is 5 halves, the whole fraction cubed. So the volume is 4/3 times pi, or pi over 1 if you want to put it in fraction form, times 5 cubed over 2 cubed. 5 cubed is 5 times itself 3 times, which gives us 125. 2 cubed is 2 times itself 3 times, which gives us 8. Then we look and see if there are any common factors that will divide out, numerator and denominator, and we notice that 4 and 8 are both divisible by 4. 4 goes into 4 once, 4 goes into 8 twice. 3 and 125 are not divisible, since 3 and 5 weren't. So this is it. Now we multiply the numerators together. 1 times pi times 125 is 125 pi. Multiply the denominators together. 3 times 1 times 2 is 6. So we get 125 pi sixths. And this is cubic centimeters. There's the exact volume in terms of pi of that billiard ball. Example 5. A company packages salt in a container composed of a cylinder and a hemisphere. Now, a hemisphere is simply exactly half of a sphere in the same way that a semicircle is half of a circle. So it's called a hemisphere, not a semisphere, as shown. So here's our hemisphere, half of a sphere, and here's our cylinder. Salt weighs 1.25 ounces per cubic inch. What is the weight of the salt in the package shown in pounds? Okay, so the first thing we need to do is find the volume, because if we're going to use this ounces per inch and then change it to pounds, we're going to need, we already know the ounces, but we need to find the number of cubic inches that represents the 1.25. So we're going to create a ratio that's 1.25 ounces per so many cubic inches. So we need to find the volume first, or the mass. This will give us a good ratio of the weight. So the first thing, again, is we need to find the volume of this composite figure. So first of all, the volume of the composite here is the volume of the cylinder. Then we're going to add to that half the volume of a sphere. Hemisphere is exactly half a sphere, so this would be half of this volume of the sphere. So then at this point, the volume of a cylinder formula is big B, there the base face, times the height of the cylinder, plus, and then 1/2 times the formula for the volume of a sphere, which is 4/3 pi r cubed. Big B, of course, since it's a circle in the sphere, the base face is going to be pi r squared for the area. So substituting that into here, we have pi r squared h plus, and then 1/2 times 4/3. Notice that 2 and 4 will divide out. 2 goes into 2 once, 2 goes into 4 2 times. 1 times 2 is 2. 1 times 3 is 3. So we get 2/3 pi r cubed. So this right here is a formula, or the formula we can use, one of the formulas that we could use to find the volume of all of this composite figure. Notice that we can factor out the radius, both radii, both for the sphere and the cylinder, are exactly the same. So these are the same value, so we could factor out 2 of those. There's r squared here and r cubed here. We can also factor out a pi. There's a pi in each of these two terms. So I'm going to factor out pi times r squared, and that leaves me in the first term with h plus, and over in the second term I'm left with 2/3, and there's one more r factor. So this is even a more efficient formula to use for the volume of this. Next, let's get our dimensions going here. We've got our sphere and our hemisphere, and then we have our cylinder. In the hemisphere, all we need is the radius. So the radius is 3 inches. They give it to us. In the cylinder, we need the radius, which is also 3 inches, but we also need the height of the cylinder, which is 5 inches. Well, that's not 3, that's 3/2, isn't it? That's diameter was 3. All the way across diameter. So the radius would be 3 divided by 2, or 3/2, in both. So there's everything we need. Radius is 3/2 inch, or 1.5 inches, and the height of the cylinder is 5. So we come over here and start substituting in. We have pi times the radius, which is 3/2 squared, times h, height, which is 5 of the cylinder, plus 2/3 times r, or radius, again, is 3/2. So this is your plug-in step. Notice that on the outside of this bracket or grouping symbols, we have pi times 3 halves squared. So let's square the 3 halves. When we do that, we square the 3, we square the 2, and we get 9 over 4, or 9/4 pi, times, and then over here we need to multiply before we add. So we have 5 plus, notice here, 2/3 times 3 halves, the 2's divide out, the 3's divide out, and we get 1 over 1 times 1 over 1. 1 times 1 is simply 1. So we get 5 plus 1. Now we have 9/4 pi times 5 plus 1 is 6. I put the 6 over 1. Notice that 4 and 6 are divisible by 2. 2 goes into 4 twice. 2 goes into 6 3 times. And so we get 9 times pi times 3, which is 27 pi, over the denominators, pi over 1. 2 times 1 times 1 is 2. So 27 pi over 2, or 27 halves pi cubic inches, is the exact volume of this composite container. Now I'm going to go ahead and write a decimal for that, so our work with ounces and cubic inches will be a little easier. Plus, this is already in decimal form. So 27 pi over 2, when you divide 2 into 27, it's 13.5 pi cubic inches. So the volume that we're going to use for the container that's 1.25 ounces is right here. So the second thing we do, coming back up over here, is we find the weight. So we're going to use density. And density, of course, is ounces to cubic inches. It's mass, weight to mass. And so we can create out of this 1.25 ounces for every 1 cubic inch. Set up a proportion, and that can equal a variable like W for weight, ounces, is to 13.5 pi cubic inches. So we use this. So again, we set up a proportion. Ounces to cubic inches is ounces to cubic inches. We use our weight for salt and density, 1.25 ounces per 1 cubic inch. And over here, the W comes up here across from ounces, and what we found in cubic inches is down here on the bottom level. Then we can cross multiply. 1 times W, of course, is W. And then we have 1.25 times 13.5 pi there. And then when we multiply 1.25 times 13.5, don't forget the pi's on the end as a factor, is 16.87 pi, 875 pi ounces. And one more step, number 3. Now that we have ounces, we convert to pounds. And in pounds, we use LBS for pounds, abbreviating. And so when we do that, we take what we're trying to convert, 16.875 pi ounces, and we multiply it with the conversion factor. Well, and you might have to look this up, there's 16 ounces in 1 pound, LB. So we can set up our ratio here, either 16 ounces over 1 pound or 1 pound over 16 ounces. In this particular case, since we want ounces to disappear, we're going to put ounces in the denominator so that they'll divide out in the numerator here. So that means we have 16 ounces in the bottom of the fraction and 1 pound in the top. Now we're multiplying now. The ounces divide out, and so we're left with 16.875 pi times 1 pound or pounds over 1 times 16. Ounces are gone. So now we have 16.875 pi over 16 pounds. And when we do that, we get an approximation from your calculator. Make sure pi multiplies with this first and then divide by 16. We get about 3.3 pounds of salt. That's how much salt that this container will hold. Example 6. The volume of a sphere is 5,000 cubic meters. What is the surface area of that sphere to the nearest square meter? So this time, unlike a couple of examples ago when we were going from surface area to volume, this time they give us the volume and they're asking us to find the surface area. So again, we're going to go through the radius. That's going to be the key. They give us the volume, find the radius, and then we're looking for surface area. Don't forget, the volume is cubic units, surface area is squared units. So, first of all, we're given our volume. Volume is 5,000 cubic meters. The volume formula then is V equal 4/3 pi r cubed. We need to solve for r so that we can find the radius. So substituting in for V, we have 5,000 equal 4/3 times pi times radius cubed. In solving for r, first of all, we need to get rid of the 4/3 that's being multiplied. So we can multiply by the reciprocal of 4/3, which is 3/4. We need to do that on both sides of the equation. On the right side, the 4's divide out, the 3's divide out, they're all 1's, and we're left with just pi r cubed. On the left side, 4 and 5,000 are both divisible by 4. And 4 goes into 4 once, 4 goes into 5,000 exactly 1,250 times. So now we're left with 3 times 1,250. The denominator is just 1 now. Multiplying those two together, we get 3,750 equals pi r cubed. Now we need to get rid of the pi, which is being multiplied with r cubed, so we divide both sides by pi. The pi's divide out on the right side, and we're left with 3,750 over pi equals r cubed. Now, the inverse of squaring a variable is taking the square root. The inverse of cubing a variable is taking the cube root. Make sure the little index number 3 is there. Whatever we do to one side of an equation, we can do exactly the same thing to the other side. So we take the cube root of the left side of the equation also. Over here, the cube and the cube root cancel each other out, and we're left with r, which is what we're looking for. On the left side, we have the cube root of 3,750 over pi. Now, we need to keep this as exact as possible when we go to find our surface area. I'm going to change this to exponential form. If you have a number that you're taking the root of, it's the same as taking that number to 1 over that root. So, this right here, 3,750 over pi, taking the cube root of it is the same as taking that to the 1/3 power. This index number is in the denominator of the exponent and 1 is in the numerator. So now that we have r, we now can find the surface area. Surface area of a sphere is 4 pi r squared. Now that we have r, the surface area is 4 times pi times the radius, which is 3,750 over pi to the 1/3 power. All of that is squared. Now last year in Algebra 1, you were supposed to learn what a power to a power rule was. X to the second, for instance, and then if you cubed x squared, you would get x to the 2 times 3. You multiply the exponents when you take a power to a power. Well, this is the same thing. We have a base, a power on it, and we're taking that to another power. So we're going to multiply these two exponents. So we have 4 pi times 3,750 over pi to the 1/3 times 2 power. So the surface area is 4 pi times 3,750 over pi to the 1/3 times 2 is 2/3. So the exponent is 2/3. Now, we can't cancel these out because this is to the 2/3 power and this is to the first power. This is about as far as we can go, and now we find an approximation. So in your calculator, what you can do is put in 4 second pi times, open parentheses, 3,750 divided by second pi, close parentheses, then the caret key or to the key, and then open parentheses, 2 divided by 3, close parentheses. So all of that should be as an exponent. Hit enter, and you should get about 1,414 square meters. Now, if you ever need to just find the cube root of something, like way back here, the command for the cube root is, in the TI-84, is the math key first, and then after that, hit 4. Math 4, cubic root. Example 7. Find the radius of a sphere such that the ratio of the surface area in that sphere in square feet to the volume of that same sphere in cubic feet is 2 to 5. So 2 to 5 represents the ratio of its surface area to its volume. So surface area is 2, volume is 5. These are the two numbers they represent. They want to know what the radius of that sphere would be. That would give us a ratio of 2 to 5 on its surface area to volume. So what we can do is create a proportion. We have our surface area to our volume is equal to 2 to 5. So then take the surface area formula for a sphere and the volume formula for a sphere and substitute them in here and here. So the surface area is 4 pi r squared to the volume formula, 4/3 pi r cubed, equals 2 to 5. In any proportion we can cross multiply, so we do that next. Going this way, we have 5 times 4 pi r squared equals, going this way, we have 2 times 4/3 pi r cubed. Multiplying these two together, we get 20 pi r squared. On the right side, when we multiply, the 2 and the 3 won't divide out, so 2 times 4 is 8. 1 times 3 is 3, so we get 8/3 pi r cubed. Now, so that we don't have any fractions in our equation, we have the luxury of getting rid of that 3. So let's multiply both sides by 3. That way we can get rid of the denominator, that's 3. The 3's divide out here and here, and we're left with on the right side 8 pi r cubed. On the left side, 3 times 20 is 60 pi r squared. And the next thing we do is notice this is one full term. This is positive 60 pi r squared. This is one full term, positive 8 pi r cubed. But the r squared and r cubed make them different kinds of terms. It would be kind of like having x squared equal x cubed. So what we do is we get everything over to one side set equal to 0, much like what we do when we have quadratic equations. So I'm going to subtract 8 pi r cubed from both sides. And on the left side we get 60 pi r squared minus 8 pi r cubed. On the right side, we get 0 because this minus itself is 0. Remember, anytime you have something that multiplied with something else and it equals 0, that means either factor could equal 0. So let's see if we can factor this. 60 pi r squared minus 8 pi r cubed. First of all, 60 and 8, we can factor out a 4. So we factor out a 4. We can also factor out a pi from both terms. And we can also factor out two radii factors from both of them. So 4r pi r squared factors out. Now let's see what we have left. We factored out a 4 from 60. We've got 15 left. And we've already factored out the pi, and both are factors. So just 15 minus, and when we factored out a 4 from this term, we have 2 left. But we factored out a pi, but we still have one r factor left. There's r cubed here, r squared that we factored out. So that's minus 2r equals 0. So here's one factor times another factor equals 0. That means either 4 pi r squared, the first factor, equals 0, or the other factor, 15 minus 2r, equals 0. So we solved both equations, just like with a quadratic. Next, solving for r, we can divide both sides by 4 pi. The 4's divide out, the pi's divide out, and we're left with r squared equal 0 divided by any other number is always 0. To solve for the r, we want to get rid of the square, so we take the square root of both sides. The square root of r squared is r, and the square root of 0 is 0. So one of our factors is r is 0. Well, r represents the radius. Radius cannot be 0, and you have a sphere, so this is bogus. Over here we have 15 minus 2r equals 0, so we solve for r. First thing I'm going to do is I'm going to add 2r to both sides. And now I have 15, and then minus 2r plus 2r is 0, equals 0 plus 2r is 2r. Then I want to get rid of the 2, so I divide both sides by 2, and r is 15 halves. So the radius of this sphere that has a ratio of its surface area to volume in 2 to 5 has to have a radius, that sphere has to have a radius of 15 halves, or 7.5 feet.